So in this class, we are discussing about the construction, okay, and purpose of the coreless type induction furnace. So induction means compulsory this having the core, but here you have to use the induction furnace without the core, okay. So this is the construction of a coreless type induction furnace, okay. So in this one you have to, okay, this is the construction of the so it is like a one vessel, okay. So and it having the refractory material, okay, to avoid the insulation. And here in this one, here you have to place the metal which is to be heated, okay, the metal which is to be heated by using this coreless type induction furnace, okay. So that metal will be placed in this container, okay. So and here you having the copper conduction coils, okay. So this refractory material will be covered with the copper conduction coils. See, coming to the construction and operation of the coreless type induction furnace. See, the general design of the furnace is as shown in figure. So it essentially consists of main parts: primary coil, a ceramic crucible containing the charge which forms the secondary, okay. See here, this one will be acting as the primary conduction coil, okay. This copper conduction coil are primary, and the metal which is to be heated, okay, the metal which is to be heated itself act as the secondary, okay. So here so the, and third main part is the frame, which includes support and tilting mechanism. So here you can total covered with a frame, okay. So these are the three main parts in the coreless type induction furnace, okay. See, the distinctive feature of this furnace is that it contains to no heavy iron core, okay. So here there will be no core means compulsory. When you are using the core furnace, induction means compulsory you have the existence of the core, okay. But here I says that this is a coreless type induction furnace. So whenever there will be no core means at the time there will be no heavy iron parts, okay. And that result there will be no continuous path for magnetic flux, okay. So the crucible and the coil are relatively light in construction and can be convenient. So here you can use the crucible, okay. So this crucible and this coil are very light in construction, okay. So at that time you can easily pour the molten metal into the crucible, okay. So the charge put into the crucible and the primary winding is connected to high frequency AC supply, okay. So see here, whenever you have to giving the high frequency AC supply to this primary, so at that time, so whenever the primary there will be current flux will be produced automatically according to the mutual induction. The secondary also the flux will be produced. Whenever the flux will be linked with the secondary, automatically the current induced in the secondary. Current is nothing but it is a some amount of heat. So at that time here the metal which is to be heated is heated up to the melting point, okay. See here, the flux produced by the primary setups the eddy current in the charge, okay. Why? Because the charge itself acts as a secondary and heats up to the melting point, okay. So this is the construction and operation of the coreless type induction furnace. See, the charge need not to be in the molten state and starts as was required by core type furnaces, okay. So it is not compulsory here. The charge which is to be heated is not in the molten state, okay. So the eddy currents also set up electromotive forces. So here the eddy currents will be induced in the charge. So whenever eddy current means, so these are rotating in nature. So at that time they have produced this stirring action, okay. Stirring action which is essential for obtaining the uniform quality of the metal, okay. So since flux density, so but here the flux density is low. Why? Because here there will be no magnetic core, okay. So and a high frequency supply will be used. So here you have to use high frequency supply. Whenever you have to use the high frequency supply, so at that time it will be used eddy currents. So that's why eddy currents will be produced. Why? Because eddy currents is always directly proportional to the frequency square. So whenever frequency will be increases, the eddy current will be also increases, okay. However, this frequency increases the resistance of the primary winding due to skin effect, thereby increasing the primary copper losses, okay. So whenever the frequency will be increases, so the resistance of the winding will be also increases. So at that time the resistance will be increases, it causes the copper losses. Copper losses are nothing but I square R losses. So whenever the resistance will be increases, so at that time the copper losses also be increases. Okay, hence the primary winding is not made of copper wire but consisting of hollow copper tubes. Okay, the primary winding is not made with exactly copper material but it consisting of a hollow copper tubes, okay, and are cooled by the water circulating to them. So whenever lot amount of flux will be produced, so at that time maybe this copper will be more heated. Okay, so to cool that one, here we are using the water circulating around this. See here, see in the diagram here it surrounds the water. Okay, so this is the so since magnetic coupling between primary and secondary winding is low, the furnace lies between 0.1 and 0.3. So here there will be no iron core will be used. So that's why there will be no continuous magnetic path. Okay, so that's why here the magnetic coupling between the primary and secondary will be low. Why? Because here there is no presence of iron core. Okay, so that's why here the furnace power factor will be always lies in between 0.1 and 0.3. Okay, so that's why here you have to use the capacitors. Okay, capacitors are connected in parallel to this furnace to improve the power factor of coreless type induction furnace. Okay, so to improve the power factor of that one, here you have to connect the capacitors in parallel. Okay, so this is about the coreless type induction furnace. Now we have to see advantages. Advantages are low operating cost, okay, low erection cost, okay, automatic steering action produced by the eddy currents, okay, absence of dirt, dust, smoke and noise, okay, there will be no dust, smoke and noise, simple charging and pouring. Okay, here the molten metal will be simply charging and it is to place the molten metal into the crucible also very simple. Precise control of power, okay, less melting time, possibility of employing vacuum heating necessary for precise melting. Okay, so no contamination of charge, okay, and very accurate control of composition. Okay, so these are the advantages of the coreless type induction furnace. Okay, applications. Coming to the applications of coreless type induction furnace, use unit, okay, to melt the metal. Okay, so in that purpose here you are using the coreless type induction furnace. Production of carbon free ferrous alloys, to produce the ferrous alloys. Okay, in the formation of ferrous alloys also we have to use the coreless type induction furnace. Vacuum heating, duplexing steel, heating charges of non-conducting material. Okay, so these are the applications of the coreless type induction furnace. Okay, so up to now here you have to completing the electric heating. Okay, so in which ways you have to producing the electric heating, what are the modes of transfer to the electrical heating, okay, and what are the types of electrical heating, and you have to see the different types, advantages, disadvantages and applications of each and every one. So up to now you have to complete the electric heating. So next one you have to see the electric welding. Okay, so welding is nothing but welding is a process of joining two pieces of metal or non-metal together by heating them to the melting point. So whenever you have to take either two metals or non-metals, okay, the two metals or two non-metals are will be heated, okay, up to their melting point, okay, and by joining these two metals is nothing but welding. Okay, filler metal may or may not be used to join the two pieces. Filler metal means extra one heating material, that is also one metal. Okay, that metal will be used to join those two pieces. So in some cases maybe that is called filler material. So in some cases you can maybe use that filler metal, in some cases it is not necessary. Okay, the physical and mechanical properties of a material to be welded, such as the melting temperature, density, thermal conductivity, okay, so and tensile strength take an important role in welding. So whenever you have to welding the any metals, so at that time you have to take their physical and mechanical considerations, that is physical and chemical properties are must, physical and mechanical properties are must and should. You have to see the melting temperature, okay, as well as density, as well as thermal conductivity, as well as tensile strength, okay, metal strength you have to see. Okay, depending upon the how the heat applied created, you get different type of weldings. Okay, so here you have to do the welding. Here you have to apply the heating. Okay, depending upon the how the heat is applied is created. So how much of heat will be applied, depending upon that. Here the welding will be classified into different types. Those are thermal welding, gas welding, and electric welding. Okay, so here in this our subject, here we have to discussing the electric welding. Okay, electric welding is done by using the thermal. Okay, that means by using the temperature. Okay, and the heat, that means either by burning of the coal, when at that time you have to produce the heat. By using that heat also you have to weld. Okay, so but here gas welding, by using the gas. Okay, by using the gas also you can weld. But and electric welding, here by using the electrical current. Okay, by using the electrical current, here you have to joining the two metals, that is nothing but the electric welding. Okay, so here in this our subject only you have to discussing about the electric welding. Okay, and what are the modern welding techniques. Okay, so those are discussed in this chapter. Okay, so welding is nowadays extensively used in automobile industry, pipeline fabrication in thermal power plants, machine repair work, machine frames, etc. Okay, so nowadays, okay, nowadays welding is mainly used in the extensively used in automobile industries. Okay, pipeline fabrication, thermal power plants, okay, machine repair work, all applications we are using the electric welding. Okay, now you have to see the advantages and disadvantages of welding. Electric welding, so welding is done by either by thermal welding or gas welding, but here over upon those weldings, here you have to using the electric welding. Okay, at that time it having must and should some advantages as well as the disadvantages. So first here you can see the advantages. Okay, advantages of electric welding. Welding is the most economical method to permanently join two metals. Okay, it is a most economical method. Okay, that means in cost point of it is most economical to permanently join two metal parts. Okay, it provides design flexibility. Okay, so in which shape you can bend the metals, in that shape you have to bend by using the only electric welding. Okay, a welding equipment is not so costly and is portable. So the equipment which is used for the welding purpose, it is not so costly. Okay, cost is also less. Okay, and is portable. Okay, so it permits considerable freedom in design. Okay, both similar and dissimilar metals can be joined by welding. Here we have to join any two metals. Okay, that metals will be same metals or different metals. Okay, so welding joints are easier to inspect. So whenever you have to welding the joints, so at the time to place at anywhere, that is very easy to inspect. Okay, so these are the advantages of the electric welding. Okay, coming to the disadvantages. Okay, welding gives out harmful radiations and fumes. Okay, so whenever you have welding any metals means compulsory is having some radiation hazards. So at that time the welding gives out the harmful radiations and fumes. Okay, welding process requires skilled operators. Okay, so to do the welding process it requires the skilled operators. If welding is not done carefully, it may result in the distortion of workpiece. If suppose whenever you have to welding the two metals, so at that time you have to not perfectly welded, so it results into the distortion in the workpiece. Okay, welding needs internal inspection. Okay, so whenever you have to doing the welding process, at that time also it requires the internal inspection. Okay, so these are the advantages and disadvantages of the electric welding. See, electric welding. What is the process of electric welding? First, you can see the definition. It is defined as the process of joining two metal pieces. Okay, so it is the process of joining two metal pieces in which electrical energy is used to generate the heat at the point of welding in order to melt the joint. Here, by using the electrical energy, by passing off the electrical current through the two metals, so at that time the two metals will be heated up to the melting point. At that time you have to join those two metals. That process will be called as electric welding. Okay, the classification of electric welding process is, see, this is the classification of electric welding. See, electric welding. Electric welding is mainly classified into two types. What are those? Resistance welding, arc welding. Okay, so the resistance welding is again classified into four types. Those are spot welding, seam welding, projection welding, butt welding. The butt welding is again two types. So in some textbook it is mentioned three types and in some textbooks it is two types. Okay, butt welding is again classified into upset butt welding, flash butt welding. So third one is percussion butt welding. Okay, so but here third one is not mentioned. So third one is also percussion butt welding. Okay, so coming to the arc welding. So arc welding is here you have to give it four types. What are those? Metal arc welding, carbon arc welding, atomic hydrogen arc welding, helium or argon welding. Okay, so these are the types of welding. Okay, so here the welding is mainly classified into two types. What are those? Resistance welding, arc welding. So the resistance welding is again classified into four types. Those are spot welding, seam welding, projection welding, butt welding. So the butt welding is again classified into three types. What are those? Upset welding, flash butt welding, percussion welding. Okay, so arc welding is four types. Metal arc welding, carbon arc welding, atomic or hydrogen arc welding, helium or argon welding. Okay. So, if, first of all, you do the welding process, the selection of proper welding process depending upon the following factors. Okay, so to do the proper welding process, okay, so the welding will be depending upon the following factors. What are those? The type of metal to be joined. Here we have to join the metal. Okay, so that so it will be depending upon that type of that metal. The techniques of welding adapted. So, which techniques will be used in the welding? Cost of equipment used. Okay. So, to do the welding, you have to use the equipment. So, and it is also dependent upon that cost. The nature of products to be fabricated. Okay. So that means by using that welding, that which product will be fabricated. So the welding will be depending upon that also. Okay, so resistance. So electric welding are mainly two types. Here I am says that resistance welding, arc welding. So first one is what? Resistance welding. Okay, see, resistance welding. Resistance welding is the processing of joining two metals together by the heat produced due to resistance offered to the flow of electrical current at the junction of two metals. Okay, see, so resistance welding is nothing but, so whenever you have to giving the electrical current, so sorry, whenever you have to giving the electrical supply is nothing but at that time the two metal, the current will be passing. So whenever the current will be current is there, compulsory there will be resistance. Okay, because of that resistance, the heat will be produced. Because of that heat, the two metals will be welded. That type of welding is called resistance welding. The heat produced by the resistance to flow of the current is given by H equal to I square RT. Because of this heat production, that means here resistance. Whenever resistance will be increases, here the resistance welding heat will be also increases. So that means H equal to I square RT. Okay, so that is depending upon this process. Okay, so where I is the current through the electrodes, okay, or metals. Okay, R is the contact resistance of the interface, and T is the time for the which current flows. Okay, at which amount of time the current will be flows. Okay, hence the total resistance offered to the flow of current is made of. Okay, so the resistance of the current in the current path in the work, the resistance between the contact surface and the points being welded, the resistance between the electrodes and surface of the points being welded. Okay, so that means the total resistance offered to the flow of current is made up of, okay, that means the resistance will offer these three ways. Okay, so that is the resistance welding. See first here. So here you have to take, see, this is one electrode and this one is one other electrode. Okay, here this is a fixed one and this one is a movable one. Okay, and here these are the two metal plates which are to be welded. Okay, so that means so these are two metal plates which are welded is to be connected to, one is connected to moving one and another one is fixed one. That means this is a fixed one and this one is a moving one. So for this one here you have to giving the AC supply. Okay, that means supply electrical current. So whenever you have to giving the AC supply to primary, automatic, that means through a one step down welding transformer. So at that time the current will flow through the electrodes. This one will be fixed one and this one will be moved one. Okay, you have to mechanically, either automatically or by manually, you have to stress them into this clamp, these clamps. Okay, that means these are the two clamps or two metals which are to be welded. So this one is fixed one, this plate is fixed one and this one is movable one. through this electrode, this one is placed on this one. So here electrode means the current will pass through the electrodes. At that time they have to melt it. Okay, so at that time the heat will be produced. That heat will join these two metal pieces. Okay, this is the process of the resistance welding. Okay, so that's why here you can say that this is the electric circuit for the resistance welding. Okay, see in this process of see here, in this process of welding, the heat developed at the contact area between the pieces to be welded reduces the metal to plastic state or liquid state. Okay, that means here these are two melted. Okay, so these are coming to the liquid state and these two will be welded. Okay, so the electric voltage input to the welding varies in between 4 and 12 volts. Okay, here you have to giving the supply voltage is in between 4 to 12 volts depending upon the area, thickness, composition, etc. Okay, usually power ranges from 60 to 180 watts for each square meter area. So, and it requires the power of 60 to 180 watts. Okay, see here any desired combination of voltage and current. Okay, so any desired combination of voltage and current can be obtained by means of a suitable transformer in AC. Okay, so desired combination of voltage and current will be getted by using the transformer in AC. Okay, that's why hence AC is found to be most suitable for resistance welding. Okay, that's why here we have to giving the AC supply to the resistance welding. Okay. So magnitude of the current is controlled by changing the primary voltage of the welding transformer. Okay, so here the magnitude of the current will be changed by using the change in the primary voltage. Why? Because here we have the number of tappings on the primary side of the welding transformer. Okay, by varying these tappings, we have to vary the magnitude of the voltage. Okay. This is the process of resistance welding. Okay, coming to the advantages. Okay, welding process is rapid and simple. Okay, this process is a simple one. Localized heating is possible if required. Okay, so heating will be also localized heating. No need of using filler material. Here you have to use any extra filler material. Both similar and dissimilar metals can be welded. Here you have to see welded two metal plates. These two metal plates either will be same metals or different metals. Okay, so comparatively lesser skill is required. Okay, to do this process you have to require the less skilled person also. Okay. So it can be employed for mass production. Okay, maintenance cost is also less. Okay, so these are the advantages and disadvantages of the, sorry, these are the advantages of resistance welding. Okay, so coming to the disadvantages, so however the resistance welding has some drawbacks. Okay, so drawbacks are nothing but disadvantages. So coming to the disadvantages of resistance welding, so disadvantages are initial cost is very high. Okay, so the cost is very high. High maintenance cost. Okay, maintenance cost is also high. The workpiece with heavier thickness cannot be welded. Okay, so the workpieces, okay, the metals which are which are to be welded having very thick. So at the time it is not welded. So at the time it requires very high currents. Okay, so those are the disadvantages or drawbacks of resistance welding. Okay, so coming to the applications. So where you are using this resistance welding is means it is used in many industries manufacturing products made up of thin gauge metals. Okay, so in many industries, okay, in industries, okay, by welding of the metals, thinner gauge metals, here you are using the resistance welding. It is used for manufacturing of tubes and smaller structural sections. Okay, tubes, okay, you have to manufacturing the tubes or pipes. In that cases, here you are using the resistance welding. So, and what are the types of resistance welding? So, in previous electric welding classification already you are discussing. So, depending upon the method of weld obtained and the type of electrode used, okay, so that means depending upon the method of welding, okay, so that means which method will be you have to do the welding, okay, and the type of electrodes will be used, and what are the types of electrodes we used. The resistance welding is classified as spot welding, seam welding, projection welding, butt welding. Okay, so it is classified as spot welding, seam welding, projection welding, butt welding. Okay, see, first one is what? Spot welding. Okay, so the name itself indicates spot. So spot welding means the joining of the two metal sheets and fusing them together. Copper electrodes tips at suitably spaced intervals by means of heavy electric current. Okay, so that means see here you have to at this spot, okay, particular spot, okay, where you have to weld it. Okay, so at that time you have properly welding, so that welding is nothing but spot welding. That means spot welding means joining of two metal sheets and fusing them together between the copper electrode tips, okay, suitably intervals by means of heavy current. See here you have to take the two metal plates. That means the metal plates which are to be welded. Okay, so and these two are placed in two electrodes. One is a fixed one and another one is, so this one is a fixed one and this one is a movable electrode. Okay, so whenever you have to giving the AC supply, so primary so automatically the current will be passed to the secondary. At that time the current will pass to the electrodes. Okay, so at that time the electrodes will be melted and to produce the heat. Okay, so that at the time these the two metal plates at the particular spot, see where you have to properly weld. So at that place, at the particular spot, these two metal plates will be welded. So whenever the welding process will be done, so at that time lot amount of heat will be produced. Okay, so to cool that electrodes, here you have to using the automatically water cooled electrodes. That means in electrodes we have to place the water. Okay, that water is automatically cools the heat. Okay, so this is the process of the spot welding. Okay. See, this type of joint is found by spot welding, provides mechanical strength. Okay, and not air or water tight. For such welding, it is necessary to localize the current and to apply sufficient pressure on the sheet to be welded. Okay, here in this process, you have to welding. Here you have to apply the sufficient pressure. Okay, the electrodes here we are using the electrodes are made up of copper or copper alloy and are water cooled. Okay. The welding currents varies widely depending upon the thickness and composition of the plates. Here you have using the current for the welding process, that will be depending upon the thickness of the metal plates which are to be welded. Okay, so and it varies from 1000 to 10,000 amperes. Okay, and it varies from 1000 to 10,000 amperes. Okay, and the voltage between the electrodes is usually less than 2 volts. Okay, the voltage between the two electrodes will be less than 2 volts. Okay, so the period of the flow of current varies depending upon the thickness of the sheet to be joined. So that means the flow of current, okay, that means the welding time will be depending upon the thickness. So whenever these two plates are very thin, so at the time in a small amount of time period, so they will be two will be molded. That means the two will be welded. If suppose we are using the thickness plate, very thick plate, so at that time it is time to be taken to welding of the two plates. Okay, that means the time of period, so the period of the flow of the current varies depending upon the thickness of the sheets which is to be joined. Okay, next one is seam welding. Seam welding is nothing but series of continuous of spot welding. Spot means only at one place, at a particular spot you have to weld it. But series of, so if suppose you have to weld it with two plates at series of spot weldings. Okay, so the continuous spot weldings, okay, so that welding is nothing but the seam welding. If number of spots obtained by spot weldings are replaced very closely that they can overlap, and it gives rise to seam welding. Okay. See, this is the arrangement and construction of the seam welding. Here, here continuous continuous of spot welding. Seam welding is nothing but. Okay, so that's why here you have to not use the tip electrodes. Tip electrodes means, see, like this. Here you have to use the tip. But okay, here you have to make the continuous series of seam welding. Okay, that's why here you have to using rolling or wheel type electrodes. Okay, rolling or wheel type electrodes to join the two metal pieces. Okay, so these are all the welding spots. Okay, so this is a one spot welding. This is one spot welding. This is one spot welding. Okay, like this here you have to continuous series of spot weldings. Okay, that process is nothing but the seam welding. Okay, remaining process same. Okay, so here I have to giving the supply. Okay, so at that time the current will be passed to the electrodes. Okay, that heat will be join the two metal pieces. Okay, so this is the seam welding. So next third one is what in resistance welding, projection welding. Okay, so projection, the name is itself, you have to project the metal pieces. Okay, so that means it is a modified form of the spot welding. Okay, so it is a modified form of spot welding. In the projection welding, both current and pressure are localized to the welding points. Okay, as in the spot welding. Okay, so both here, you have to take the current and pressure in the proper localized points in the projection welding. But the only the difference in the projection welding is the high mechanical pressure is applied on the metal pieces to be welded. Here you have to apply the high mechanical pressure, okay, on the metal pieces which is to be welded after the formation of weld. Okay, so the electrodes used for such welding are flat metal plates known as platens. So here you have to welding by this using this projection welding process. So at that time you have to using the metal plates will be very flat. Okay, the two pieces of the base metal to be welded are held together in between the seam. Here. This is the construction of a projection welding. Okay, so here so in previous like this previous one, here also you have to give supply. This is a fixed electrode and this one is a movable electrode, and here you have to use first one base metal. Okay, and that base metal you have to form the welding by using this projection. Okay, that means another base metal will be projected. Okay. Okay, so that means here what I am says that here you have to the electrodes used for such welding flat metal platens. Okay, so the two pieces of base metal to be welded together in between the two platens. Okay, here the metals which are to be welded. Okay, these are the two metals to be welded. These two are placed in between these two platens. Here you have using the two platens. Okay, so the projection welding has the following advantages. See, here also process is same. So whenever, and so this means spot, and that means here you have to spot this welding. So that means in this place here we are using you have to join this metal plate and this metal plate, but here you have to using the very high mechanical pressure, and that's why here in between these two one you are using the platens. Okay, that is the only difference between the projection welding and spot welding. Okay, so the projection welding has the following advantages over the spot welding. Okay, so the projection welding having these advantages over the spot welding. So what are the advantages? Simplicity in welding process. Okay, so welding process will be simple. It is used to weld some of the parts where the spot welding is not possible. So in some cases where you have to not possible the spot welding, in that cases here you are using the projection welding. Okay, it is possible to join several welding points. Okay, that means it is useful to join the several weldings. Okay, welds are located automatically by the position of projection. Okay, these two are welded automatically depending upon the projection. Okay, as the electrode used in the projection welding are flat type, the contact area over the projection is sufficient. Okay, so here we are using the flat type electrode, so at the time the contact area of the projection will be also sufficient. So these are the advantages of the projection welding. So in last one, in resistance welding is nothing but butt welding. Okay, so butt welding. So butt welding is similar to the spot welding. Okay, so this butt welding is also similar to spot welding. However, the only difference is butt welding, instead of the electrodes, the metal parts are to be joined or butt together or connected to the supply. Okay, here but instead of electrodes, so here there will be no use of electrodes. So directly the metal parts are directly given to the supply. Okay, but in previous one, here you have to connect the electrodes. Through that electrodes you have to connect the metal plates which are to be welded. But here in this process, the metal parts which are to be welded is directly given to the supply. See here, the three basic types of butt welding process are offset butt welding, flash butt welding, percussion butt welding. Okay, so already in previous we are discussing. So first one is what? Offset welding. In offset welding, the two metal parts should be joined to end and are connected across the secondary of the welding transformer. See here, this is the primary one and this is the secondary one. Okay, so through these clampers, so clampers are electrodes, so these are directly joined. Okay, here for this clamp, here you have to place the electrodes. So whenever you have to giving the supply to the primary, this is phase and neutral. So at that time, so this is a welding transformer, welding step down transformer. So at that time the current will pass to these clamps. So directly these two will be welded. Okay, these are to be melted up to melting point. Okay, because of this heat, two will be welded. Okay, so this is nothing but the offset welding. Flash butt welding. Okay, flash butt welding is a combination of resistance, arc and pressure welding. Okay, it is a combination of resistance welding, arc welding. Later you have to discuss. So weldings are mainly two types. What are those? Resistance welding, arc welding. Okay, after completion of resistance welding, you are discussing the arc welding. Okay, here you can say that the flash butt welding is a combination of a resistance, arc and pressure welding. Okay, so this method of welding is mainly used in the production of welding. Okay, used in production. Okay, where you have to produce any metal. So in that cases, here you are using the flash butt welding. A simple flash butt welding arrangement is, see here, that means whenever whenever you have to here giving the single phase AC supply through a step down transformer, so here you have to place through clamps. Okay, through clamps here you have to place the two electrodes. So at that time the two electrodes will be placed some distance to have to maintain some distance. See like this. So whenever the current will be passed through the electrode, so at that time the arc will be extinguished between. So whenever you have to maintain the air gap, okay, so whenever the air gap will be ionized with the current, so at that time the arc will be produced. Okay, so that arc will be joining these two metals. So that process is nothing but the flash butt welding. Okay, here some arc will be produced. Arc is nothing but flash. Okay, so that's why this name is called flash butt welding. Okay. So following are the advantages of the flash butt welding over the offset welding. So compared to the offset welding, flash butt welding having these advantages. What are those? Less requirement of power. Okay, so it requires the less power. When the surface is being joined, it requires only less attention. Okay, whenever we have to doing the welding process, so at that time it requires the less attention. Okay, weld obtained is so clean and pure. Here the welding which is getting finally, that is a very clean and pure due to the foreign metals appearing on the surfaces will burn due to flash or arc. Okay, so these are the advantages of the flash butt welding. Okay. Next one is percussion welding. Okay, here the name will be missing. So last one in butt welding is percussion welding. It is a form of flash butt welding where high current of short duration is employed using stored energy principle. So here you have to apply the current by the process of storing. Okay, this is a self-timing spot welding method. Okay, this is also called as self-timing spot welding method. Okay, see, this is the arrangement of the percussion welding. Okay, so here we have to use the one movable clamp, one fixed clamp. Here by using the capacitors arrangement, you have to store the energy. By using that energy, here you have to welding these two metals. So so that means the percussion welding arrangement consisting of one fixed holder and the other one is movable one. Okay, so this is a moving one and this one is a fixed holder. Okay, so the pieces to be welded are held apart with the help of the two holders. When the movable clamp is released, it moves rapidly carrying the piece to be welded. Okay, so there is a sudden discharge of electrical energy. Okay, so that means here by storing of the capacitors, you have to store the energy, electrical energy. Okay, and then you have to discharge that energy. Whenever the energy will be discharged through the electrodes, at that time the arc will be struck between the two surfaces and heating them due to their melting temperatures. Okay, see here what is the process means. By using this one, here you have to connect so by using the transformer, here you have to get the AC. Here by using the rectifier unit, here you have to convert this AC supply into the DC. Okay, so here you have to connect this switch. Okay, and this total energy will be stored in the capacitor. Okay, so whenever the switch will be closed, so at the time the energy discharges from the capacitor is passing through the two electrodes. So at that time these two electrodes are melting to their melting points. At that time these two metals will be welded. Okay, so here clamps means to hold the this one is a movable clamp and this one is a fixed clamp. Here this metal plate will be fixed and this is movable one. Whenever this one is directly falls on this one, so at that time these two metal pieces will be welded. Okay, so see here, there is a sudden discharge of electrical energy which establish arc between the two surfaces and heating to their melting temperature. When the two places are separated by a distance of 1 meter, as the pieces come in contact with each other under heavy pressure. Okay. Okay, see here when the two pieces, okay, here when the two electrodes are separated by a distance of 1.5 meters. So at the time the two pieces are come in contact with heavy pressure. So whenever this contact with heavy pressure, so the arc is extinguished due to the percussion blow of the two parts. So at that time maybe arc will be also extinguished. And that means it is a form of flash butt welding. So that's why I will say that. So whenever you have to move the 1.5 meters apart, so at that time maybe arc will be also produced. Okay, so that arc will be maybe also cause of the welded. Okay, the percussion welding can be obtained in two methods. One is capacitor energy storage system and another one is magnetic energy storage system. So here in this one, here you have to show the capacitor storage system. Okay, so this is the type resistance welding. Okay, in which ways we have to do the resistance welding and types of resistance welding. What are the types of resistance welding? Spot welding, okay, seam welding, okay, projection welding, butt welding. Butt welding is again three types. What are those? Upset butt welding, flash butt welding, percussion butt welding. Okay, so next one is what in welding? Electric arc welding. Okay, so here next one is what? Electric arc welding. Electric arc welding is process of joining two metallic pieces or melting of metal is obtained. Okay, here also you have to joining the two metallic pieces or two metals by the use of arc. Okay, so see, due to the heat developed by an arc electrodes and metals to be welded. So whenever the arc will be struck between the two electrodes, so at that time due to that heat, the two electrodes will be welded. Okay, that process is nothing but the electric arc welding. Okay, so see, this is the arrangement of electric arc welding. Here this is a welding machine, AC or DC. Okay, that means to give the supply. Okay, so first this one is a work. So that means the work which is to be welded. Okay, so this is a holder to maintain the electrode holder, to place the whenever you have to put the electrode near to this one. So here the current will be passing through this electrode, and here the current will be passing through the work. So at that time these two will be the, so at that time the workpiece and here the electrode. So at that time in some space is there, air gap. So in that air gap the arc will be struck. Okay, so arc means heat. So at that time because of that heat the metal parts, the metal is to be welded. That is nothing but the electric welding. Okay, so this is the arrangement of the electric welding. Okay, for arc welding the temperature of the arc should be 3500 degrees centigrade. Okay, to welding by using the electric arc welding. So at that time you have to maintain the temperature of the arc will be 3500 degrees centigrade. At this temperature mechanical pressure for melting point is not required. Okay, whenever you have to use the whenever you have to maintain the high temperature, at the time there will be no mechanical pressure will be required for the melting. Okay, both AC and DC can be used in the arc welding. So here you have to use either AC supply or DC supply. Okay, usually 70 to 100 volts on AC supply and 50 to 60 volts on DC supply system is sufficient to struck the arc in the air gap between the two electrodes. So to struck the electrode between the two electrodes, if suppose we are using the AC supply, at that time here you have to require the 70 to 100 volts. If suppose you have to giving the DC supply, so at that time it will require 50 to 60 volts. Okay, once the arc is struck, only 32. So when first to struck the arc, these are the temperatures required. Once the arc will be struck, so at the time only 20 to 30 volts of the energy is sufficient to require to maintain it. So at that time only 20 to 30 volts of energy will be required. Okay. However, in certain cases there is any danger of electric shock to the operator. Low voltage should be used for the welding purpose. Okay. So suppose there is a chance to any shock to the operator, so at the time maybe you have to use the low voltages also. Thus the DC arc welding of low voltage is generally preferred. Okay, that's why at that time you have to use the DC voltage. Why? Because DC means you have to use the less amount of voltage. Okay, electric arc welding is extensively used for the joining of metal parts. Okay, so this electric arc welding is used for the joining of metal parts as well as the repair of fractured casting and the filling by the deposition of new metal on the base metal. Okay, so etc. Okay, and the repair of fractured casting and the fillings by the deposition of new metal on the base metal. Okay, so these are the applications of the electric arc welding. See, coming to the various types of electric arc welding are carbon arc welding, metal arc welding, atomic hydrogen welding, inert gas metal arc welding, submerged arc welding. Okay, these are the 5 types of the carbon arc welding. So, what are the 5 types? Carbon arc welding, metal arc welding, atomic hydrogen arc welding, inert gas metal arc welding, submerged arc welding. Okay, so these are the 5 types. Okay, so in this one, first one is what? Carbon arc welding. Okay, so it is the first one is carbon arc welding. It is the one of the process of arc welding in which arc is struck between the 2 carbon electrodes. Okay, here the arc will be struck between the 2 carbon electrodes. Okay, so that's why this is called carbon arc welding. Okay, two are the carbon electrode and the base metal. So either 2 carbon electrodes or one is carbon electrode and another one is the base metal. Here first you can see the simple arrangement of the carbon arc welding. See here. This one is DC supply here I have given. This is electrode holder. Okay, to maintain the electrode holder. See here base metal. Okay, the metal which is to be welded. Here this one is a electrode. Okay, through the clamp you have to stick this electrode. When you have to giving the DC supply through to this electrode and this base metal. So at that time the arc will be struck between. So here in between the electrode and base metal you have to maintain some distance. So in this distance that air whenever through the air the current will be passes, at that time the air will be ionized and it will be struck the arc between the electrode and base. Okay, at that time by using this arc you have to welding this base metal. This type of welding is called as carbon welding. Okay.